Dear boys and girls, my dear sons and daughters, welcome to YouTube channel Shashwati Shama. This is an educative channel that guides the budding degree and diploma engineers in their pursuits of technical knowledge. Before I go into the depth of discussion with you about the power plants, especially the thermal power plants, I like to introduce myself. I am Parthapratim Rai, ex-Deputy General Manager and Head of the Department, Power Plant Simulator Training Institute, and finished the execution of last 15 years of services in simulator. As I told you, I shall discuss with you different aspects of power plant. And among these power plants, our main focus will remain on thermal power plant, and especially Bakreshwar Thermal Power Station and to some extent Kolaghat Thermal Power Station. Because in the tenure of my full service life, I have worked in these two thermal power plants. Apart from thermal power plants, if you agree and allow me to discuss with you the other subjects of mechanical engineering, because I am being a mechanical engineer, I would like to share the knowledges on fluid mechanics, hydraulics, machine tools, thermal engineering, and such other subjects with you to enrich your wealth of knowledge and help you to get through successfully in the coming exams and interviews come out with flying colors. Dear boys and girls, I request you and also suggest you that you see the video till the end carefully, and if this discussion that I want to do with you about the power plants, the other subjects of mechanical engineering in the coming videos, you do not forget to leave your comments in the comment box, and do not forget to push like button, subscription button and the bell icon to make and boost me up for producing such attractive videos which will come in good stead, as I think, which will come in good stead in your future life. Now I tell you some points on vocational training for which most of you have come to Power Plant Simulator Training Institute. What is the vocational training and what is vocation? The vocation is the profession that you are going to pick up in your future life. After passing the exams, final exams in your college and university, your profession in the industry now require your pre-acquisition of experience in industry during your college and industry life, in your study life. Why this is required? Because the industrial entrepreneurs demand it. Why they demand? Because they spend a lot of money upon you to get you trained in the processes of industry that they run. And if you have preliminary knowledge of industrial processes, and if you get hands-on training in industry before you join the industrial enterprises in your post-educational life, then it will be added advantage to the industrial entrepreneurs, because they will have to spend less money and get more benefit from you. And hence the course planners in your institute, that is college and universities, have planned to introduce the sessional vocational training in your course curriculum. I give you a statistical information which explain why you are required to get industrial training during your college life. In the year 23-24, the pass outs of technical and engineering colleges, 60% of the students were technically sound. That means they had a good knowledge in technology. But 40% of them, that is 24% of the total number of students, only were capable to be industrially suitable, that they could be absorbed in the industry. Only 24% of the total boys and girls were suitable for industrial recruitment. But 60% were technically sound, but all were not able to convert their technical knowledge into the practical field that is demanded in the industry. So, my boys and girls, my dear sons and daughters, do not leave any stone unturned during your classroom and plan visit training in the industry and also in the college and university in which you do read, because all your knowledge, either theoretical or practical, are very much required in your recruitment procedure. You want the recruitment in the industry. Your objective of learning technology is to get services in the industry, and industrial entrepreneurs require your beforehand knowledge in industrial processes. And here I stress one important requirement on your part, that is, do not leave the classroom without clearing the list of doubts in the subjects, because every day's classroom will give you platform for jumping into the next class, next subject matter. You have seen that in a book, the previous papers will give you the preliminary things, and as you go on reading the pages, the deeper you go into the subject, the more difficult things come up. And if you do not clear the doubts in simpler ideas, then you will not be able to catch hold of the difficult matters you are coming to encounter in the coming phases of studies or the books you are going to study. Here you have come in the power plant of Bakreshwar Thermal Station to learn to have simulator training. Simulator, in brief, I tell you, a set of computers which represent or gives the replica of real life control room, that is the heartland of a power plant. The control room is a place wherein the power is actually generated in the generator. Simulator consists of a set of computers, initially the instructor station that controls the total training program fully. The servers provide the brain behind the programming of the total training system, and operating workstations give you the human-machine interface by which you learn the operations or the procedures by which the generation is done in the actual control room of reality. Now you will get an experience of control room in the simulator system. In the simulator control room, you will get the experience of a real life control room system wherein you will experience the generation of the method of generation of power. I have told you that heartland of power industry is the control room, and you will get the first-hand knowledge of it, you will get hands-on training there on power generation through the simulator control room and simulator system of power plant. What is power? The question of power is that, the definition is that the amount of work done in unit time. What is work done? Suppose you apply force F on a body of mass m and the body undergoes a displacement in time t, the displacement is say L. Then the amount of work done by the force F is given by F into L. Force into displacement is the amount of work done of a body. Now, from historical point of view, when machine was not available to the human being, the muscle power of human being and also the muscle power of animals were being used to do the work, and especially the lifting of water from the deep wells. The horses would have been used to raise water from the deep well in the past. And remembering the use of horses in every work and especially the lifting of water from the well, James Watt, who is at the root of invention of steam engine, defined the unit of power as horsepower. That is, if a horse or a machine does work in such a way that it produces 550 feet-pound per second or 3000 feet-pound per minute of work, then the power of that machine or that horse is called the 1 horsepower power. That is the British unit and also the gravitational unit. Suppose you bring water from the well, deep is 10 feet, and you bring up 55 pound water from the well, then the work done in unit time, suppose you take 1 second time, then you do 5 feet pound of work in 1 second time, and your power expended to do that work is 550 feet pound per second or 1 horsepower. Now I have told you about the very definition of power, its historical background, how horsepower came into being, and the unit. That is, 1 horsepower is the unit of power. In the metric system, the unit of power is watt. And how this watt is defined? If 1 Newton force produces in 1 kg of body a displacement of 1 meter, then 1 Newton meter, or you may say joule, 1 joule of work done is there, and if it is done in 1 second, that is 1 joule per second of power is produced by the machine that forces the body a displacement of 1 meter, then the power is called 1 watt. And if 1000 watt is executed, the amount of power is 1000 watt, then that is called 1 kilowatt. Now I tell you about the electrical power. What is the electrical power? That is the electrical machine generates. What is the electrical machine generate power? That is generator in the thermal power station. In the thermal power station, there are so many equipment, but the most vital equipment is generator, which actually generates the electrical power, utilizing which we run AC machine, ceiling fan, microwave, refrigerator, and so on. And this generator is run by Faraday's law of electromagnetism. What is Faraday's law of electromagnetism? Faraday's law of electromagnetism says if the lines of magnetic force linked with a coil go on changing, then due to electrical effect of magnetic field, an EMF is generated in the conductor. Remember, the lines of magnetic force linked with the conductor need to be changed every time. Otherwise, there will be no generation of electromotive force. What is electromotive force? This is an electrical force. Suppose you are pushing a book on the table, it is mechanical force you are giving on the book. But the electrical machine generates EMF when it is not externally connected. The force that tries to send electron into the external circuit is called electromotive force. You see, the name says electromotive force. That means the force that tries to create motion in the electrons. So, you can understand what is the meaning of electromotive force. And when the system is connected to the external field or external circuit, the electromotive force is called the voltage. Now I am explained in a very short manner how Faraday's law of electromagnetism produces the EMF, or from EMF the current from the electric effect of magnet. In generator, mainly there are two parts. One is stator, having turns of coils, and a rotor that rotates by the rotation of turbine shaft. The turbine shaft is connected with the rotor of the generator, and as the turbine shaft rotates by the steam from boiler, the generator rotor also rotates. And through the coil in the rotor, a DC or direct current is sent, preliminary you say from the battery. And this current is maintained so long we want electricity from the generator. Now this flow of current gives the magnetic effect of current. That means several lines of forces of magnet are generated, and stator with the coils are placed very near to it, and the lines of magnetic forces get linked with the conductors. And as the rotor rotates, the lines of force of the magnet linked with the coil in the stator go on changing. And if you change the number of coils, the magnitude of EMF generator will change. If you change the number of lines of forces linked with the coil, every time if you change, then there will be change in the EMF. Because the vital 2 points which require to be changed to change the EMF is number of turns and number of lines of forces linked with the coil of stator. And mathematically expressed, Faraday's law is given by EMF is equal to N into d phi dt. N is the number of turns in the stator coil, and d phi dt is the change in lines of magnetic forces linked with the coil of stator. The source of rotor's motion is turbine. And turbine is called the prime mover, the main mover of the rotor. The turbine is rotated by the steam. So, the kinetic energy of turbine is converted into electrical energy. Here, some of the track I tell you, if you are asked to say that what is the source of electricity in the power plant, it is not heat energy, because heat energy comes from the chemical energy of the coal and oil. So, the chemical energy is converted to the electrical energy in the thermal power plant. Potential energy of the water is converted into electrical energy in ideal power plant. And nuclear energy is converted to electrical energy in the nuclear power plant, and so on. Now, the electrical power, as I told you, that it is equal to voltage and current. I define this voltage, and before that I tell you, for your easy understanding, what is called Coulomb's law and how is it expressed mathematically. Coulomb's law says, if some point charge is q1 in a space and at r distance a similar point charge of q2 is placed, then what will happen? There will be repulsion. I know, or you all know, that the similar charges repel, that is, similar charges attract. Now here is q1 charge and here is q2 charge. There is the intervening distance r. Now the permittivity of the intervening medium is, say, epsilon 0. Then what happens? The force between these two similar charges may be dissimilar. For your easy understanding, I tell you that repulsion is equal to F is equal to 1 by 4 pi epsilon 0 or 1 by k into q1 q2 by r square. 1 by k is equal to 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0, very specifically q1 q2 by r square. What is the relation between r square and f? F is inversely proportional to the square of the distance between the charges. What does that mean? If q2 is taken away from the q1, that is, r is going on increasing, then f is going to decrease, goes on decreasing, and suppose 10 times the distance is increased, then force is reduced 100th time. If 20 times the force is increased, then F is decreased 400 times, and so on. And if this charge Q2 is taken to infinity, then R is infinity, and any finite number divided by infinity is 0, you know. So Q1, Q2 being finite values of charges, then their product is finite and divided by infinity square, that is very, very big number, comes to 0, and so F is 0. So in infinity, any field of a charge becomes 0. And if you bring a similar charge to very near vicinity of the first charge, then their distance becomes nearly 0 and force becomes very, very big. You may not bring it to each other in contact because their force is very, very high. That is nearly infinite. Now, work done in current electricity is also important. From the statical electricity point of view, if you explain electrical work, then you say, I have explained the Coulomb's law, that is F is equal to Q1 Q2 by R square, and E Q1 charge has a field around it, and at our distance we want to know the voltage there. Actually we say the potential there. It is called potential. This is the amount of work done in bringing unit charge from infinity to that point. What is the unit charge? That is, suppose 1 ESU. There is some Q2 ESU charge concentrated at a point, and from its earth distance, earth centimeter earth distance, we want to bring unit 1 ESU charge from infinity to that point. We do the amount. Why we do work? Because there is repulsion. We have to overcome repulsion. So you see, if there is opposition before you, when you are swimming against the flow of water in the river, you have to do much work against the flow of the water. When you are going upstream, when you go downstream, you need not do any work, useful work, because the flow of water will take you downward. Similarly, if there is attraction, you need not do any work. It automatically is attracted and some work is expended. Here you are working on the unit charge. And suppose it is V. Okay. Now I tell you, the work done in current electricity, it can also be defined or explained in the statical electrical point of view. I am coming to that. Before that, I tell you, some electrical charges are passing through the conductor of resistance R, and the passage of electron is taking place in time t. So current electricity point of view, work done is I square RT. And if you divide it by t, suppose the battery is sending this amount of current I through R resistance for time t, then its power is I square R, because amount of work done is I square RT, divide it by t and get I square R, the power of the machine that is sending the current into the external circuit. I have told you about Coulomb's law. Now from Coulomb's law, we explain the voltage or potential at a point from a point charge, that is, for unit amount of charge, say the similar charge is brought to that point and amount of work done is, you say, is V. If unit charge does the work V, then what will the Q charge has to work before it reaches there is VQ. Suppose V amount of charge, Q amount of charge you was bringing from infinity to that point. So the amount of work done would be VQ. For unit charge it is V. For Q charge it will be VQ from unitary system. Suppose you take T time to bring Q charge to that point and do the work VQ. So what would be the power? That machine has the power to bring Q charge to a particular point where unit charge takes V amount of energy to go there. That is VQ by T. T time is required. I told you about the work done in current electricity, that is I square RT. Here we have defined I as the flow of charges in unit time. Suppose Q is the amount of charge flowing through a conductor in time t across a cross section, then I, or the current density, is Q by T. Here Q amount of charge is brought from infinity to a particular point of the field is in time t, that is the current is obviously Q by T is equal to I. So the amount of power that is expended in bringing this charge is V into I. Now, what is voltage? I told you. this is the pressure or the force of electrical origin that wants to send, or actually it sends the electron into the external circuit. And EMF is the pressure or force that want to send electron in the external circuit when circuit is not made, external circuit is absent. At that moment the amount of pressure or the force that tries to send electricity flow into the external circuit. For the EMF, the electricity flow is established in the external circuit, and when external circuit is connected, the force is called voltage. So, EMF and voltage are interconvertible in sense. Interchangeable, not interconvertible. I made a mistake. Interchangeable. You may say EMF when external circuit is not there, it is voltage when external circuit is there. Think of voltmeter. When the zinc rod and copper rod are not connected externally, the accumulation of charges in the zinc rod and copper rod try to send electrons in the external circuit and feels a pressure. And this pressure is electromotive force. It tries to send electron in the external circuit. The moment you connect zinc rod and copper rod with a copper wire, there will be flow of electrons. And the EMF interchange into voltage. Actually, I tell you, just a little of the track is that E is equal to capital I capital R plus capital I small r. Small r is the internal resistance. In the voltage, there is no internal resistance is taken into account. So EMF is a little bit greater than the voltage. But naturally, from their natures, they are similar in nature. Okay. Now, I have explained what is voltage and EMF. Very simple. Now, you see the power in the electrical machine is VI, I have told you. Voltage and current in multiplication. And this voltage and current have no phase difference. This is DC power. That means the phase angle is 0. Most of you have learned that in polyphase current, P is equal to VI cos alpha. Alpha is the phase angle, the phase difference. And cos phi is the phase difference, and alpha is the, or cos phi or alpha or phi is the phase angle between the voltage and current. And when alpha or phi is 0, cos 0 is 1. That is, voltage and current is giving you DC power. My dear boys and girls and my dear sons and daughters, so far I have discussed the very preliminary thing. I will go in deep discussions in coming videos if you push me up by pressing like button, subscription button and bell icon, and promote my endeavor of making videos such that I can enrich your wealth of knowledge in technology and also make me fortunate to get or to gather knowledge from you, that you will leave in your comment box how would you like it, what other topics you want to discuss with me, and also the questions you have in your mind about the subjects we are going to discuss. I will try my best to reply them to your maximum satisfaction level, and also learn from you the very basics of mechanical engineering and power plant technology in the course of discussion. Thank you, my sons and daughters. I bless you and wish you best of the luck.